everyone, welcome. My name is Victoria Sampson. I'm the Washington Office Director of the Secure World Foundation, a small nonprofit that focuses on the long-term sustainable use of outer space. Thank you for joining us today for this new webinar in the GVF webinar series in association with Connectivity Business News. And thank you to the sponsors of today's webinar, who are the creators of the new online training material for those in the space and satellite industry, Space Business Qualified. These courses are a great way to onboard new staff, broaden knowledge of existing staff, and prepare staff for increased responsibilities. Additional information is at spacebq.org. Let me introduce today's panelists. Alphabetically, we have Frank Bax, who is the Senior Vice President of Kratos Federal Space. Mr. Bax joined Kratos in January 2017, has spent over 30 years in the satellite command and control industries. Mr. Bax is most recently Chief Executive Officer for Braxton Technologies LLC and Braxton Science and Technology Group, leading manufacturers of command and control software for intelligence, military, and commercial applications based in Colorado Springs, Colorado. Our next speaker is Dr. Mark Dickinson, Deputy CTO and VP Space Segment in Inmarsat. Since 2018, he has been responsible for the design, procurement, and launch of Inmarsat's future space segment assets. From March 2017 to September 2019, Mark was appointed as the chairman of the Space Data Association, an international not-for-profit organization that brings together commercial, civil, and government satellite operators to support the controlled, reliable, and efficient sharing of data critical to the safety and integrity of the space environment. Mark remains Inmarsat's SDA Executive Director. And our last panelist is Maurizio Venazzi, Vice President, New Markets, OneWeb, where he defines their strategy for global leadership and access to finance by advancing sustainable global standards at an international and national level. Prior to this role, he was CCO of Tyvak International SRL. He was head of missions and systems department at SSTL. In this role, he was responsible for the space systems design and satellites integration, telecommunication payloads, and ground segment and operations. So before we hear our fantastic panelists, I'd like to give a few remarks introducing the concept of space sustainability. Is it too late? The more than 7,000 active satellites currently orbiting Earth provide tangible social, scientific, security, and economic benefits to billions of individuals all over the globe. Yet the ability to continue to provide these important benefits from outer space is now threatened by a number of challenges. Earth's orbital space environment constitutes a finite resource that is being used by an increased number of space actors. The proliferation of space debris, the emergence of a large number of new space actors, the rapidly increasing number of satellites in orbit, and the increasing variety and complexity of space operations pose an increased risk of collision and interference with the operation of space objects. In addition, the increasing use of space by militaries around the world creates the potential to spark or even escalate conflict. As more countries integrate space into their national military capabilities and rely on space-based information for their national security, there is an increased chance that any interference with satellites could spark or escalate tensions and conflict in space or even here on Earth. Taken together, all these developments pose risks to the safety of space operations and raise concerns about the potential for the severe degradation of the space environment, rendering it unusable for the space systems that form part of the critical infrastructure of many states. Space sustainability refers to addressing these challenges collectively to ensure that the space environment remains suitable for exploration and use by the current and future generations of all countries. Such is the growing international concern about space sustainability that in 2019, the United Nations Committee on Peaceful Uses of Outer Space adopted a set of 21 internationally agreed consensus guidelines for the long-term sustainability of outer space activities. In the preamble to these guidelines, space sustainability is defined as, quote, the ability to maintain the conduct of space activities indefinitely into the future in a manner that realizes the objectives of equitable access to the benefits of exploration and use of outer space for peaceful purposes in order to meet the needs of present generations while preserving the outer space environment for future generations, end quote. It is in the interest of all stakeholders, including the commercial sector, to be involved in establishing the best practices for safe and sustainable space activities. So today's panel will examine the space landscape and developments in the space arena from a space sustainability perspective and suggest ways in which we can all work together to ensure the long-term sustainable use of outer space. I'd like to just start off with, it seems like a very broad, but I think an important question to really set the conversation. How do you define space sustainability? How do our panelists think about space sustainability? Who'd like to start off with that?
If you want, I can go first.
Please.
So your definition of space sustainability sounded very complete to me. The way I view this is that it's getting to space in a way which doesn't create any long-term lasting effects in the environment, being able to operate safely and in a responsible manner, designing spacecraft in an appropriate way to ensure that they can perform their mission life, and then be when it comes to end of life and time to decommission, they can be safely decommissioned. So ensuring there's no long-term degradation of the space environment. With the advent of, we've doubled the number of active spacecraft in the last 4 years, and I'm sure that's going to increase at an ever faster pace. At what point does that become non-sustainable is something we need, this is vitally important to look at. And also part of your the definition you provided, which I think is very important and sometimes gets overlooked, is that it's an equitable use of space. This space isn't just for one nation or one particular company. It's for humanity and needs to be protected for generations to come, but also for maybe countries who aren't involved in space activities at the moment.
Yeah, thank you, Bert. And that's one of the things we'd like to point out is that pretty much everyone on this planet is a user of space data in some way, shape, or form. So whether or not someone belongs to a country that has satellites or even, you know, a space agency or what have you, they still have an interest in space sustainability. Maurizio, what's your take on this?
And I fully agree with what Mark said and your definition that you provided, Victoria. A couple of important aspects regarding, you know, space sustainability is the use of the word space environment, which I think that brings closer to the non-space industry people, you know, the understanding of what we're really talking about. Most of the non-experts, you know, tend to think about space as an infinite concept, which, you know, to a certain extent is, but for what space operators are concerned and, you know, fleet operators, it's a very, very finite resource, is a limited resource. So linking space as a natural resource that is available, you know, for mankind, you know, for present generations, but as Mark was saying, you know, also for future generations, and linking the concept to the space environment has to be treated and used responsibly as a finite resource, I think is a key concept that we need to instill not only in the minds of, you know, the experts, but also in the mind of the people that you know, are watching us.
Yeah, no, thank you, Maurizio. That's a good point to highlight the environmental aspects, because I think it's fairly, well understood and accepted that here on Earth, we cannot do whatever we want to the planet, where there are certain things we're going to have to do to make sure that, you know, planetary resources are still there for us in the long term. But it's taking a shift, I think, and a lot of the users for space have recognized, as you said, it is a finite resource. Particularly, we're discussing, I think, more Earth orbit than anything else, right? There are certain orbits that are starting to get filled up and starting to become a challenge to be used. Frank, what's your take on all this?
Well, my take really comes around as we enter into this environment and we start to gain a lot of new players, commercial, military players into the space environment. What we recognize is that, you know, the congestion of space objects and the radio frequency spectrum congestion combined with dual use of space technologies for military and commercial purposes really has increased to the point where space monitoring, space traffic management, and spectrum orbit management are required for us to secure safe and sustainable use of the space sector. The challenge that we see is that these functions are not coordinated activities. We have the International Telecommunication Union that manages RF spectrum licensing. Space traffic management is a very distributed services, and in many cases, certain space operators are doing their own space traffic management as much as they can. But that service isn't, has an unsure future from a funding and financial sponsorship perspective. And then, of course, the space domain awareness activity is primarily run by nation states that are not always motivated to share threats to the global space community. So really, before we dive into, I'm going to say, regulations as the answer to the challenges of space sustainability, we may want to develop as a community the ability to gain awareness of the space domain as a common global space community, and make sure that we have access to that comprehensive space domain awareness information and make that a foundation for engagement in the space sector.
Yeah, and I think you highlighted a really important way in which to look at that, and that there has been a fractured approach to ensuring the sustainability of space and how to promote that. And some of that just comes from, again, and this is kind of a ground up sort of approach. Not every country has a space agency or a national regulatory framework, and it's kind of been piecemeal. And maybe that was effective in a different space environment, but the way the domain has evolved, I think the governance really has not kept up. And I also like the fact that you identified spectrum orbital management, because oftentimes, and I'm guilty of this myself, talking about space sustainability, we tend to think about the physical objects in orbit. And of course, that is a complicating factor. But again, space is only as good as the information that we can get down from it. And so if the spectrum is an issue, that's just as big a concern to space sustainability.
Correct.
So
Yeah, on the spectrum side, just to hit that point a little bit, we don't see collisions in space necessarily every day, but we definitely see spectrum interference and spectrum congestion issues every single day. So some of these activities are occurring on a regular basis.
Yeah, actually, so building on that, Mark, you're wearing your SDA hat. Yeah, a spectrum is something that you guys look at as well, correct?
Yeah, and the way we started, when we started 12 years ago or so with the SDA, we essentially had a dual approach. We were looking at the orbits and also the spectrum. As we developed, what we found was operators are far more willing to share information about their orbits or where their satellites were and when they planned to do maneuvers than they were ever willing to share about frequency plans and about when interference was going to happen. Where we did find some benefit or some help was when one of our members had a interference event. We can tell them who their neighbors were and who may have transponders to be able to help geolocate a source. But we always have much more resistance about sharing that sort of proprietary information about how payloads are configured, and far more engagement in terms of, the satellite's going to be over here this time next week. And because people see the orbits and treat the orbits in somewhat, you just see the telescope, you can see what's up there. It's that the frequency side and the spectrum management is all a bit more. It seems to be a bit more held more proprietary than maybe it could be hoped for.
It's fascinating. Maurizio, is spectrum a concern for OneWeb, given the large constellation you guys are working on?
Yeah, I mean, spectrum for telecommunication operators is really representing the foundations of what our company are built on. And I often use the analogy of real estate. So think about situations like Hong Kong or Monaco, where real estate is really at the premium, and the consequence is that taller buildings started being constructed. And it's quite a good analogy for spectrum, because that means that operators over the time started to move higher up in frequency usage. So you see use of frequency spectrum going up and up and up and up towards higher frequencies. So there is an element of managing the spectrum in the frequencies that are mostly used at the present, but also there's another element associated to the future use of higher frequencies and also the advancement in technology and a more efficient of the spectrum that is currently heavily congested. So there's a regulatory aspect, but also a technological aspect that is playing a key role.
So yeah, that actually leads to my next question. In terms of technologies and usage, what are some of the biggest or bigger disruptions to space sustainability? I think we've identified spectrum sharing and allocation as one of those. What else would you guys say as a panel is a big, change that's disrupting the sustainable use of space?
I can start.
Please.
For sure, in-orbit servicing is key, right? And I guess that everyone agrees is a new page of our industry that is about to be written. Is a new market. I'm saying is a bit, the far west, but is in a very positive and creative way. There are two aspects related to the allow me to say the sustainability of this business. I'm using this word again, which is associated to two things. One is the business model, and the other one is the technological approach, right? So the two things have to go hand in hand. We as OneWeb, started since the very inception of our constellation to have a responsible approach to this, which means that our generation 1 satellites are equipped with docking features, whether these are mechanical features or magnetic features, that in case of a catastrophic event, meaning loss of control of the satellite, even if the satellites are designed for controlled re-entry, but in case of a catastrophic event, the satellites are compatible with a docking servicer that would enable to grab them and bring them down and having an assisted re-entry. So these are technology piece, but if you look at constellation operators, what is really difficult is let's assume we have failures we cannot buy, or financially would be extremely difficult to procure, to purchase a dedicated mission for each one of the satellite that, God forbid, are going to fail. So when I talk about this technology piece, but there's also the business model piece, I think that for these kind of ventures, these kind of new in-orbit servicing providers, the real business model, the real game changer is, the AAA in the US, the AA, the RAC is the car servicing model. Or actually, if you have a car breakdown, you have companies out there that will be able to serve multiple customers. So I think this is going to be the biggest enabler, and that will enable, from a technical perspective and also from a business perspective, these in-orbit servicing ventures to thrive.
Right, because not every satellite operator is going to be like OneWeb, where you're building in a way in which to catch it in the long term. Especially a lot of satellites that are older enough, they're already wouldn't have had the opportunity to be built with that. I think my concern for that, and I agree with you about the need for that sort of thing, is who's going to be the anchor tenant to really provide the support and make it a business model. Because right now, I think a lot of companies for active debris removal. There's a lot of enthusiasm on developing the technology, but right now, especially for low Earth orbit, there's just not a business case for it. I'm hoping that will change as more operators start to be like OneWeb and thinking ahead about it. What about you, Mark or Frank? What do you guys look at in terms of the disruptors to affecting space sustainability?
So I'll pick up on two bits. So the first one, just on active debris removal, which I think will in the future have an important role to play. We just have to be a bit careful that it can't be used as an excuse for lowering the reliability of a spacecraft to not be able to self-clean up. It has to self-clean up first. The active debris removal has to be the last resort if all things fail. So we shouldn't look to any relaxation in terms of spacecraft design, because there could potentially be a technology in the future that clean up the mess. I think the analogy here is on climate change in terrestrially, and carbon capture. It's always been talked about as a technology to be able to help solve the problem in the future. But economically, as you pointed to, Victoria, the economics of it can be challenging. The economics of active debris removal for a LEO constellation is hard. There's many orbital planes, there's many altitudes. So yes, it has a place. but it should really be for that very last resort remediation of getting that thing getting an object out of orbit safely. The other aspect I'd point to is the commercial ventures around space situational awareness. I think one of the real positives we've seen in the last 5 or 6 years is companies like Leo Labs, X-Analytics, Comspot, who are bringing to the capabilities to operators to have far better resolution in terms of where objects are, not just active objects, but also passive objects, where debris is. It's that sort of new capability that can come to market and provide services far quicker than the government can, which I think will help improve the space situational awareness side to be able to help mitigate collisions. Today, we know if you look at the ESA debris report that's produced every year, in LEO, we're not even getting 60% decommissioning as per the regulations today. We need to get much, much higher. And I know Maurizio and OneWeb and the folks at Starlink are looking for much, much higher reliability to be able to self-decommission. It's really important that we change what's happening at the moment, because we have standards, but they're not being met today. We need to make sure spacecraft design is robust so we can meet those standards.
Yeah, good point. I mean, and I think building upon your idea that, okay, we can't just let technology save us. There's still a responsibility to be able to provide good, spacecraft design. Much along those lines, well, I think the commercial SSA sector is astounding. They've been able to do such amazing things. And it's really within the past, I don't know, 5-6 years we've seen, I hate to say explosion, we're talking about space, but really an explosion in terms of SSA, commercial satellite operators, really enhancing knowledge. And I think it's great. But I think there's also a responsibility at a basic level for providing SSA. I think that's a public good, and so I would hesitate to say, well, SSA should only be commercial, because I think it's to every operator's benefit to make sure that everyone has at least a basic concept of spacecraft and debris, so that there isn't any collisions on orbit and affecting everyone's ability to use the space domain. Frank, I've been talking a lot. What's your take either on active debris removal, or if you want to talk about what you think of as a disruption to space sustainability?
Well, we've talked a lot about, like in the space situational awareness perspective, and understanding where a space object is an important aspect of, I'm going to say, threats from a collision perspective. But as we move forward and we start putting in our plans for where orbits are going to be, where spacecraft are going to be, it's the planning process that is critical to sustainability over a long period of time. Planning not just for where your constellation of satellites is going to be, but also what spectrum you're going to use to communicate. So that upfront planning process is critical. One of the missing elements that we have today, just from a cooperation perspective, is I'm going to say the monitoring of whether or not different space systems are following the plan that they submitted. And one of the things that we really don't understand exactly how it's going to impact space is, how I'm going to say, a very dense layer of low Earth orbiting satellites from a communication standpoint are going to operate with, high throughput satellites at the geo belt. And how does that interaction between the two play out? We've done plenty of simulations about how that's going to play, but I don't think anybody entirely understands the answer. And then, of course, the big question is, without a monitoring function existing somewhere, it is difficult for the ITU to validate whether or not people are following the plans that they submitted, or for that matter, from an orbit perspective, we're seeing under the guise of space, I'm going to say servicing, we see nation state satellites that are on orbit in geosynchronous and other areas that could be nefarious. And so it's very difficult without a clear space domain awareness understanding and close proximity operations understanding to be able to attribute if somebody is doing something outside of the accepted plan.
Right, and I think, it's an interesting question. You're talking about who's responsible for following through or making sure operators do what they're saying they're doing too. Wouldn't you say that's almost a failure of countries to follow their Article 6 obligations in the Outer Space Treaty? For those of you who are familiar, the Article 6 Outer Space Treaty requires nations to provide continuing supervision for their national actors. And so, I mean, you go back, I mean, that's, I think the very basic level would be at the nation state. But I'm curious what you think, Frank, about that. Or is it just that maybe some actors don't have the capacity to provide that continuing supervision? Or if it's just not a priority, like, why are we seeing this?
Well, I think primarily it's a lack of being able to monitor and attribute the activity that is occurring, or an unwillingness to share that information, mostly because of, you know, the methods to gain that level of fidelity in space domain awareness tend to cause that information to become classified or highly controlled. So it isn't shared or discussed in a more public environment. But as we add commercial operators or commercial space domain awareness players into the equation, those networks of sensors and all the rest are going to be generating unclassified information and, you know, and data about what's going on in space that isn't controlled by any particular nation state. So I think we will over time be able to generate more knowledge about what's going on and the ability to attribute behavior. Then the question is, where are you going to go if behavior is outside the plan? And that's right now, that's a little bit challenging, right? You have the UN on a generic level with the space treaty. You have the ITU from a, you know, RF spectrum perspective, but those organizations don't have a lot of authority. So it'll be an interesting challenge as we move forward. But again, I think the first step is gaining awareness of what is occurring.
Right. I mean, I think for a lot of the people, the international organizations not having teeth, that is a feature, not a bug. You know, but particularly, you know, looking at the concern about, you know, what SSA can provide. I mean, space situation awareness, it's only as good as establishing patterns of behavior. And they need to figure out, okay, well, how do you analyze that behavior? How do you move on with that? And that's something I think that not every actor has the ability to do, or at least the ability to incorporate it, or maybe it's not even a big priority at this point, but I think that's going to have to change in the near future.
And over the last 4 years, there is an organization that has been established specifically for some of this purpose. It's the Space ISAC, the Space Information Sharing and Analysis Center. And that organization has 53 different companies in the space market already, the space sector, that are members. And one of the purposes of that organization is to be able to gather this data from a space domain awareness perspective and be able to provide it out in an unclassified and global community basis. So it'll be interesting to see how that organization comes together moving forward as well, to maybe close some of the gaps in the information available to space operators.
I want to build on that thought, but also I'd like to remind the audience that I can ask questions all day long, but we're starting to see a few questions in the Q&A. I'd like to remind you, if you have any questions for our panelists, I'd love to try and work them in. There's a button at the bottom of your screen. Please feel free to share them in the Q&A. And again, please do not put them in the chat. I have been told to ignore anything that shows up in the chat as question related. So for that. But yeah, so building off the topic we were discussing, maybe Mark or Maurizio, you guys may have some thoughts on this. You know, what responsibility does the commercial sector have in promoting space sustainability? Frank brought up the Space ISAC, and there's other commercial industry associations such as the Space Safety Coalition, or confers in the consortium execution running and servicing operations. So Mark Maurizio and then Frank, where do you guys see about the commercial sector? What role can they play in promoting and enhancing space sustainability?
Well, I certainly feel that the commercial actors have a responsibility to be able to actually undertake their missions as per the plan and invest the right money in systems to ensure that they can meet the guidelines of the best practice, but also as a community to educate and to improve. And there's a lot of people out there who know the issues that we're facing, very smart people who want to ensure that space is sustainable and can the benefits to humanity can carry on. Engagement, awareness, learning, but importantly reflecting those learnings in spacecraft design. And from a regulatory point of view, I'm sure we'll come discuss the regulators at some point, but you've already mentioned in your opening remarks the regulators falling far behind the technology evolution, what's happening. And it's important that while regulators get it back up to speed, and I hope they need to eventually, and have capabilities to be able to do their job and assess what's going up into space and the things that's up there are being managed successfully. It's incumbent upon the commercial sector to be able to work together in a collaborative way to be able to make sure that we don't create issues that are going to be. And the thing about space is a global commons. If I have an issue, then it becomes someone else's issue in due course. So we have this responsibility to act in good faith and work together to try and get the best to be as sustainable as we possibly can.
Thank you. What about you, Maritza? What do you think?
Yeah, fully agree with what Mark said. And as you know, OneWeb is already operational. So we have not waited to get off the starting blocks in this regard. And some people might know that OneWeb has helped to define responsible orbital practices with our fellow operators, SpaceX and Iridium. And while we fiercely compete on the marketplace, truth to be told, we have been closely cooperating with, these are the constellations in order to come up with, these best responsible orbital practices, best practices. And also we have an open line regarding, any potential risks of collisions, and we constantly talk about how to handle proximity events and how to manage, in an harmonized way, traffic when we cross each other orbits. So on this regard, we really think that trying to act and be a role model, not only in making sure that we present these in these kind of panels, but also making sure that on an operational level, we implement what we preach, right?
Right. No, and that's a really good point. In terms of being able to practice what you're preaching in these discussions. We have an interesting question from audience members saying it was noted that some of the operators are not meeting the standards in terms of deorbiting. And just in general, what are consequences of not meeting standards, if any?
From a space, go ahead.
As far as I'm aware, there are no real consequences. There's no real repercussions. The regulatory environment doesn't impose anything because something. Obviously, the nation state, as a launching state, has responsibility for the object overall in terms of its activity in space. But yes, if you fail to decommission a satellite as per the guidelines, there are no real repercussions. You don't have to pay anything, or you may get some more questions next time you try and get a launch license to launch something again. But that's really the extent. There's no real, as far as I'm aware, or I haven't seen any provisions that require people to forfeit a bond or pay money from the insurers or anything like that for failure to meet guidelines, because they are guidelines.
Right. Other thoughts?
And I would agree with that entirely. There's no, I'm going to say, direct financial or economic impact to not following the plan that you put in place to get your access to space assured. But an interesting aspect of the space community as a whole is that in most cases, if you're operating in a particular regime like low Earth orbiting or mid Earth orbiting, and you don't manage your spacecraft appropriately at end of life, you're affecting your own neighborhood that will eventually affect you as an organization. And that has some effect and of course drives a lot of cooperation between the companies that operate in, I'm going to say, close orbit regimes to each other. And so there is a lot of natural cooperation occurring just within the commercial space industry because you don't want to pollute your own neighborhood. And so there is some motivation there. It's certainly generating a lot of good behavior. One of the challenges that we have, though, is if a company, let's say, goes out of business and they have a lot of satellites on orbit, the question is what happens, to, let's say, 10,000 satellites that went on orbit and the company that was managing them is no longer viable financially. What happens to that infrastructure? And today, there really isn't much of an answer for that.
All right, I think we only had one circumstance where a relatively large satellite operator went out of orbit and it was immediately bought up, which Saved by the bell in that case, but we're not.
That's right.
Maurizio, what are your thoughts on this?
Well, no nation should authorize the launch of any object unless that nation has assessed the impact of that object and its launch on the space environment as a whole. But more often than not, we have to deal with the consequence and the aftermath of some instances where we have flags of convenience, where satellites are being launched under national regulations that are, let's say, less strict. So in that regard, and I'm going to be very, very vocal about this, ultimately the solution goes back to market access. So you could argue that the only way to hurt these companies, you're not going to be able to convince someone in dodgy countries to pay a fine. There's no international regulatory body that's be able to convince them. But if the leading countries will start saying, okay, you know what, you're not going to be able to operate your service in my country because you are a bit dodgy in the way you operate, then we're going to start impacting those businesses. So for me, market access and access to finance is one of the ultimate ways to impose these kind of regulations.
And actually, I'm really interested. Oh, sorry. I was going to say I'm really glad you brought that up. Oh, sorry.
Go ahead.
Please go, Mark.
Okay, I was just going to agree with Marissa there. Right? Market access is the one, or landing rights is the one thing that the regulators have power over. My concern is that I agree with the sentiment that the regulators should have the ability to be able to make an assessment before something is launched, to be able to do that activity. My concern is they don't have the technical capabilities today to make that assessment, or they're under-resourced to be able to make it. So the whole space capacity discussion, how big is space, how much can you put there, is a difficult question. And we don't really have consensus about what there is finite. It depends upon the size of spacecraft, it depends on the mass of spacecraft, cross-sectional area, how many, which orbits. To make the regulators find it very difficult. And it's such a competitive environment that I think they struggle. And I think I attended a webinar with Greg Weiler recently. He said the regulators used to send letters to each other in quite a nice way, but now they're stuck in the middle of a knife fight and they don't really know what to do. And I think they are struggling to be able to make those intelligent assessments before granting a launch license, exactly what the impact is. This isn't just really launching one system, it's a system of systems issues. One constellation or one system is going to interact with another system, either by when the orbit raises or decommissions. So making a true assessment of what the real risk is hard. And I don't even think as industry should be helping to try and articulate some metrics of space capacity, because we need some quantifiable way to make that assessment of what the risk of launching something is. And I don't think we really have that. So I think regulators don't have the tools to be able to make that assessment before granting a launch license today. And I think that situation has to improve.
So it's not necessarily a matter of commercial actors doing, as Rita said, either flags of convenience or looking at forum shopping. And it just might be that there's a matter of the regulators not being able to keep up or not even having the basic research and development to make these informed decisions, is what you're saying. Particularly when going into like carrying capacity, which is an issue that my organization has been looking at a lot. The idea that is it possible that at a certain point, certain orbital shells will get filled up? And I don't think anyone's saying it's going to be like, the movie WALL-E, where there's, this wall of debris, what have you. You have to pop on through to get out of Earth's orbit. Nothing like that. But at a certain point, there may become some orbital shells where there's enough of a chance of interference, whether it's physical or radio frequency, that it's not to your benefit. It's too costly to operate in. It's too dangerous to operate in. I'm curious to know, what do you guys think? Is carrying capacity something that you think about or are concerned about, or is it something that is overrated? What's your take on this?
I'm happy to start on this one. You used you referred to the movie WALL-E. I often in the past refer to the arcade game. I think that we're all old enough to remember the Frogger. The 80s, so there was that little frog trying to cross the road. Yeah, I think people are nodding. So there are multiple ways of looking at these, right? One is specifically related to how many satellites can we fit in one specific orbit, and I think is a really, really difficult concept. To measure how many angels. Can you fit on the head of a pin? How big are the angels? Or how wide is the pinhead? And I think that enhancement in technology will really help us, to make better satellites, more efficient, and we're going to be able to fit more capacity into orbit. So the problem with orbital carrying capacity implies, that there is a limit, and not necessarily think that is true is where this limit is based on the current technologies that are available to us, to space manufacturers and to space operators. On the other hand, and I think this is the key part, is not only about how many satellites can you squeeze on a specific orbit, but going back to my analogy of the Frogger arcade game, you also have to think about the number of satellites and the congestion on one specific orbit, especially if it's in low Earth orbit. Is this gonna limit the ability to reach higher orbits? Because you can imagine fast forward in 30, 40 years from now, a cloud of clutter that is orbiting in a low LEO orbit. Actually, is going to create the physical barrier that you were referring to, that Wally is facing to reach higher orbits. Is going to make space operations launches even more and more complex. So it's in this regard, I think that's a problem we have to look from two different perspectives.
Definitely. Frank or Mark, what's your take on carrying capacity?
Go ahead, Mark.
Okay, yeah. So I think it is an important area that we do need to develop. We need to get better metrics and something quantifiable. At the moment, the whole problem is not really quantifiable. We can't make an assessment of risk, and it's really important that we get to some way of measuring that. And in somewhat, it has some analogies again to climate change terrestrially. And if you look back at the history of climate change, it was like the 50s and 60s. They started understanding about how the atmosphere worked. I think we're now understanding really about space and how now we're occupying large parts of it, exactly what the problems are. Then the models get developed, and then you start running those models, and then it starts showing a problem. So coming back to the question of this webinar, is it too late? I truly hope it's not too late, but I think we need to develop those models to be able to make a fair and reasoned technical assessment about whether we do have a problem and if we do have a problem, how we mitigate it. I don't think we want to be in COP37 and having a space discussion as well as a terrestrial discussion. So I think it's incumbent upon us to build the technical models to make a true analytical assessment of what the risk is. And now we're seeing it's not just people get wowed by the numbers of spacecraft, and it's true. We've launched, and the space community's doubled in the numbers of active spacecraft has doubled in the last 4 years. But also different types of spacecraft. We're now seeing spacecraft with 900 square meter potential reflectors. That's a big area.
It's huge.
That's a big target. But we're also seeing satellites that are far more massive. We're seeing next generation constellations which are 5 times the mass. So the target area might not change, but the consequence of a collision could be far bigger because you have far more mass. So the ability to be able to determine what that technical collision risk is and management in terms of the true characteristics of each individual spacecraft, how they're deployed, and then really importantly, how that system interacts with other systems. So we can sometimes look at systems in isolation. This is a constellation, and it may operate at one altitude, but as I said, eventually you'll have to interact with other things. You have to go up and down. You have to replace. I think we need to get far better and be able to have a framework, a model to be able to make reasoned technical assessments of risk.
And as we move forward with that, in any kind of modeling environment, the accuracy of the information that we're working with, the fidelity of that information, right, really builds or degrades our confidence in that model. And today, the accuracy of space debris and spacecraft themselves is not great. In other words, most of the time when there's a collision threat, scenario, one of the things that most of the space operators are going through is trying to figure out what is the error associated with that collision threat that they're facing, and is the risk of maneuvering actually higher than staying where I am when it comes to avoiding a collision? Because you could maneuver right into a collision if the accuracy of the data is not very good. And today the data is not real accurate, and it's also not kept real current. I would say when you're talking about geosynchronous satellites, the data within any orbit slot is pretty accurate and maintained pretty closely. But when you're talking about LEO and the speed at which objects are approaching each other and those types of things, the accuracy of the data is extremely critical. And especially if you're maneuvering up through the orbital planes, right, and going from one regime to the next, or coming back down in a disposal operation, accuracy of that collision information is critical. And today there's no economic environment that supports a dramatically higher accuracy model than what we're working with today. The companies that are providing space domain awareness data, are, I'm going to say, operating at very marginal economics. And so it's hard to envision an economic environment where that space domain awareness data becomes valuable enough to increase its accuracy to our current requirements. So anyway, so from my standpoint, yeah, the model is going to be really important. We do have the technology to become more accurate. We just don't have the economics to drive it.
All right, and I think the plethora of SSA providers, that is a benefit. I won't say a curse, but it's a complicating factor because, as you say, you can get multiple sources, and how do you depend upon which one is the one that, if you need to move? Along those lines, just the idea, there's been a lot of discussion. I like the Frogger concept about, moving through constellations, but even within an orbital sphere, there's starting to be the discussion, should there be a right of way for satellites? As far as I know, the only agreement, and I'm willing to be corrected on this if anyone knows differently, the only agreement I know of is that actually Starlink signed an agreement with NASA about a year and a half ago. They said, okay, if it's a Starlink satellite coming close to a NASA satellite, the NASA satellite gets priority and the Starlink has to move. But that's the only agreement that I know of. And obviously, I don't think we can do one-off agreements from operator to operator. There's just not a way of doing it. At a certain point, I think we have to think about right of way. But what does that mean? Does that mean the biggest satellite moves, the oldest satellite moves, the smaller satellite moves, the newer satellite moves? Like, what do we think about that? What's your guys' take on this?
So,
Well,
sorry, go ahead, Frank.
I was going to say, just from my background in, operating a fishing vessel, there are the rules of the maritime environment on who moves. When I'm out in the middle of fishing in the, in the lanes where there are large ships, the bottom line is I move because I'm more maneuverable, and the economic impact to me moving is dramatically less than the economic impact of let's say, an oil transport vessel moving. And so I think maritime has some good basis of understanding when it comes to those types of things. In space, being forced to move is an incredibly economic, has a huge economic price to the owner of that spacecraft.
Frank, you're stealing the words from my mouth. I wanted to use the International Maritime Organization analogy, and it's spot on. I also would like to add something else, that today we have 460 satellites in orbit, and we receive an average of 50,000 messages a day from JSPOT. Okay, does not mean that we act on all of these 50,000 messages. We have, artificial intelligence and machine learning techniques. The consequence of that, the outcome of that, is that we really consider about 8 messages per day once they've been filtered out. But even before maneuvering, because when you maneuver, that means that you have a potential collision. What is really, really key is coordination between operators, right? And obviously, the operator we coordinate the most is Starlink, but also Iridium. So you want to make sure that if you're heading, in two cars heading in opposite direction, if one swerves on the right and the other one swerves on the left, what's going to happen is going to crash. So coordination is key. And in this conversation also, we make sure that any automated maneuvering systems or techniques are disabled, because we want to make sure, again, repeating myself, that we coordinate first. So coordination.
Good point.
And I would echo the same. That's where the SDA came from. Its foundation was, let's get operators together to share operational information for the greater good. And I always like the analogy with the IMO and seafaring and how rights of collision regs at sea. The history of it is actually those collision regs came into force after a disaster. They came into force after a collision of two boats in the River Thames in London in the 1800s and 700 people dying. We have a habit of only creating the regulations and the rights of way when we have a global commons after the event. So I'd hope for space, maybe we can learn that lesson and put them in place before the big collision happens, rather than wait until after and be reactive.
Yeah, let's hope it doesn't take a tragedy for us to be able to think ahead about these sort of things. I'd like to move over to some question or two from the audience. There's one from Adam Boyle that I'd love to hear your thoughts on. It says, how can the commercial industry raise awareness that space is a common good? We've discussed this a little bit, but specifically increasing investor awareness and long-term costs of bad behavior in space. What is the role in the investor community in promoting space sustainability? What's your guys' thoughts on that?
So maybe there's an initiative that's starting, a sustainability kite mark that's being put forward as a way of getting actually the ESG investor community to, as a flag to show that an operator meets a certain standard, has a certain kite mark, as an investment opportunity. So it allows the people who don't need to be fully educated in the ins and outs of space engineering to make an assessment about, here's an investment I can make in something which is sustainable and for the greater good. And as always, there's always, and from Nimbus at Hat, we published a report recently about the awareness of space and how it's viewed and the greater good for societal benefit. I think we all, as part of the space community, we always need to be talking about that. We need to talk about what the benefit is, so people understand the value that their day-to-day lives have a huge amount of component from services or data coming from space, and we're all part of that ecosystem, and it's our job to be sort of evangelists about how important that is. And that's why it's so important to protect the space environment, because it's vital that we can have those services now and we can develop them for the future.
Thank you. Maurizio or Frank, what's your thoughts on the role of the investment community in promoting space sustainability?
I wanted to mention what Mark said about the kite mark in the UK. Both Mark and I, are a member of that initiative, and is one of many that in particular is UK led. There are many others. There's a space sustainability rating. The EU is trying to do something similar, and these are let's say international recognized standards that will translate and make comprehensible to non-experts what space sustainability means and what space sustainability is.
Thank you. Frank?
Yeah, and that was, the biggest challenge there, right, is a lot of the investment community is investing in the economics of space as opposed to the understanding of the technology that it represents. And so it's very difficult for the investment community to make assessments like space sustainability. So I agree, that having some of these organizations that they can lean on to help define space sustainability and start to understand some of the risks is an important piece of the equation. If they have access to that information, I think investors actually will use it. But but generally speaking, they struggle with having the technology or the understanding in-house to apply that to the risk profile of the investments that they're making.
I mean, I think we can all see with our experience the past couple of years of the pandemic, we are not a scientifically literate society. And so I think that has a lot of consequences, not just for public health. Shifting gears a little bit, I wanted to bring up something that this week is the 1 year, I hesitate to say anniversary, but 1 year since the Russians tested an anti-satellite weapon, but they deliberately destroyed one of their own satellites with an interceptor launched from the ground that directly impacted the satellite on orbit at an altitude of about 470 kilometers. Which is a pretty populated orbit, low Earth orbit, created about 1,500 pieces of trackable debris. And of course, trackable is an important qualifier because it no doubt created thousands of pieces of debris that were just too small to track. It could be dangerous. And in the past year, certain SSA operators like Comstock have identified what they've said are conjunction squalls in terms of a lot of close approaches for the debris from the anti-satellite test to Earth observation satellites in low Earth orbit. And I think, in fact, every Earth observation satellite in low Earth orbit has had at least one conjunction approach with Russian ASAT debris. So that's a very long-winded way of introducing, the concept of counterspace capabilities. What do you guys think? Are the proliferation of counterspace capabilities, whether it's anti-satellite tests or the interference with radio frequency or what have you, is that something that you guys think about in terms of space sustainability? Since we have a very recent example of a counterspace effort really leaving a negative and harmful effect on the space environment.
Well, I think, definitely, I think that it really falls into the category of dual use of space. When you're overlapping commercial and military in the same environment, those kind of conflicts occur. We're seeing that in the ground, right, between the Russian-Ukraine conflict, right, where you're trying to operate a country in the middle of a war. It's if the space domain becomes too much of a warfighting domain, it's going to continue to be extremely difficult to operate commercial systems within that environment. The unfortunate part about space is you can't exactly put country borders around the problem. And so, as we continue to move forward as a society using space, I think we have to be very careful with the way that we operate in space so that we don't just move continuously toward a warfighting domain.
Thank you. Other thoughts, Mark Maurizio?
Yeah, I agree with what Frank says. The concept of an anti-satellite test creating all this debris into many different orbital altitudes, it seems nonsensical. And I'm glad to see a number of countries coming out subsequently and essentially ruling out that. I know the US led that way first, and then I know UK and Australia have also followed in terms of saying they wouldn't perform such a test. It seems that we haven't learned a lesson a number of times now. This isn't the first time it's happened. In terms of dual use and additional threats, it is something we have to think about, and it's SSA and spatial awareness is more than just orbits. It's also about potential threats and capabilities, and dual use items like docking capability could be a great benefit for in-orbit servicing, end-of-life decommissioning, but it very clearly has a dual use item there, or a dual use capability. So we do need to be very cognizant of that sort of what's in orbit, what capabilities are, and make sure that we have good visibility in terms of what's happening. So activities are transparent. So making sure that if something nefarious is happening, you can call it out. And I think that the ability for attribution and for calling it out is a strong disincentive. For bad behavior.
And I will point out in the United Nations right now, it's in the middle of a 2-year effort to do exactly what you said, Mark, the idea of identifying what is responsible behavior and what is irresponsible behavior in space, so that these bad actions can be called out, and the impact of the national community coming together and saying this is something we have identified as irresponsible action, as opposed to, say, like a geopolitical rival making a comment about it. And I also, for those of you in the audience who aren't familiar with what Mark was referring to, the United States in April this year made a commitment not to conduct destructive anti-satellite missile tests, largely because of the the long-term debris that's created from those sort of things. And has since been joined by 8 further countries, 9 countries that do that, and that have said they're going to do that. And then just earlier this month, there's a UN General Assembly resolution sponsored by the US and about 10 other countries, basically calling for an anti-satellite test moratorium. And over 150 countries voted in support of that. So it seems like, I think the international community is really coming together to say, okay, this is a norm of behavior that we would like to say, this is an irresponsible action. We think it's a norm to say this is a bad thing. And hopefully this will make the space environment more predictable and stable, which is important for all actors, including the commercial sector. So that's my way of saying I hope the commercial sector comes out as strongly as Mark did in support of this sort of ASAT test moratorium, because I think it's very much to the commercial sector's benefit to ensure that your investment is not interfered with and that you can operate safely and efficiently and reliably in the environment. But I've been talking, again, I get so excited I talk a lot. Maurizio, did you have any thoughts on this matter for Counterspace?
Yeah, I just wanted to state something obvious, but we all acknowledge that satellites are in a way or another, part of the national critical infrastructure of our countries. Whether Earth observation satellites, weather satellites, telecommunication satellites in particular, navigation satellites. And they are also in a way or another becoming potential targets in case of an international conflict. So we've seen these already on the ground in the Ukraine, how the navigation signals in L-band has been disrupted, which is calling for potentially using different frequencies to augment the navigation capabilities. We're actually stressing to a certain extent the resilience of a distributed concept for telecommunications like a constellation that in some cases increase, again, the level of resiliency compared to single bigger targets. But this is not an either or, is really making sure that we have also alternatives in the way we provide our service, because again, it's undeniable that space and space assets have become a target in case of international conflict.
Thank you. We've gone over time, but I have permission to ask a few more questions if the panel will permit me, and the audience can stick around if you can. There has been a discussion. We've talked a little bit about best practices and what standards if people are actually implementing what's being said, and there's a reference to end of life practices. Right now, the best practices within 25 years of end of life of that satellite, operator has to do something with it, whether it's deorbit it, bring it back down so the Earth's atmosphere can destroy it, or take it up to graveyard orbit 300 kilometers north of GEO. There's been a discussion that maybe 25 years may have made sense back in the day, but currently it's not quite as valid given how many satellites there are, and is that still needed? And so the FCC, the U.S. Federal Communications Commission, came up with a year to say, okay, it's not 25 years, it's 5 years. Now, this does not mean it's U.S. government policy as of yet. That's my understanding. The FCC decision kind of surprised other branches of the U.S. government. There's an agency discussion going on. But I think we can all agree that 25 years is probably not going to be the way of the future. So, I mean, what do you guys think? Is this proposed 5-year rule good, bad? Is it shifting the blame elsewhere? Do you support it? What do you think about I guess I should say shortening the end of life plans for satellites? Thoughts?
As I can start, as OneWeb, actually we've been pushing these, behind the scenes publicly for quite a long time. So extremely pleased and very, very supportive. Going back to one of the points that Mark made at the beginning is related to licensing of satellites that will be launched in the future. The licensing bodies, the regulatory bodies, also need to make sure that they have the technical competence to do this assessment, right? Because it's not just about saying, oh, I have a propulsion system on board, tick, done. It depends, what kind of reliability at system level you can provide with your overall technical solution. So it's not just about a ticking box exercise, but it's about making sure that the solution implemented is viable and reliable.
Thank you. Other thoughts?
Yeah, and I think we welcome the reduction from 25 to 5 years. As you say, 25 years probably comes from a different era. And I know the SEO and the OneWeb team and probably Starlink team and the big constellations are all planning hopefully less than 5 years as well as part of their active decommissioning. I would just, one word of caution is we've got 40% of LEOs who aren't even making the 25-year rule at the moment. So we have just reducing the rule from 25 years to 5 years doesn't fix the problem. Hopefully it gives another metric for people who are assessing reliability of systems, another point to judge against. But we already have an issue here. We've already got satellites up there which aren't meeting a 25-year rule. They're not suddenly going to make a 5-year rule because we changed the rule. So we should, yeah, it's a step in the right direction. I mean, and I think most people absolutely welcome it. I'm not sure the exact technical background why 5 years, not 4 years and 6 years, but so be it. 5 years is a number, and it's better than 25. It's just we should be trying as best as we should be as short as possible at end of life, and we need to be able to have some form of accountability if it doesn't happen.
Frank, do you have thoughts?
Yeah, I was just thinking the same thing from a, is 5 years the right number? I think, quite frankly, it ought to be part of the orbital regime plan that goes in when you're submitting your request to put up satellites in a particular orbit. Is there ought to be a plan, and 5 years might make sense, or even less than 5 years might make sense for an incredibly low Earth orbiting constellation, but where a higher level orbit, it may not make sense, right? 6 years or 10 years might be the right answer. Clearly, when you get up to much higher orbits, middle Earth orbits and geosynchronous orbits, the approach has to be different. So really, from my standpoint, what I'd like is the idea that there would be a plan, and there would be some way of tracking whether someone is following that plan. And that's where that coordination activity across the community is important. Is for us to figure out how to operate not in so many independent stovepipes, but to figure out how to come together as a community to at least attribute people not following their plan so that we can at least address them in a public sense.
Building upon the idea of a plan, one of the issues I think is often overlooked when we're talking about space sustainability is the role that cybersecurity plays in space systems. The idea that you need to bake cybersecurity in from the very beginning, just because otherwise there's just openings for interference or violations or what have you, and that in and of itself could lead to a cascade chain that could affect space sustainability, whether it's a failure of a satellite or interference with its ability to use. What do you guys think? What role does cybersecurity play in space sustainability, and doing enough for it? And what does the commercial sector think about that?
Yeah, and I think cyber's been the one big growth area in satellites in the last 5 years. If you came to the Inmarsat Control Center 5 years ago, you would have seen the network control center and the satellite control center. You go there now, you see a different cyber control center. We have more people doing cyber than we do having spacecraft. Protecting those assets as well as you can from a cyber perspective is absolutely fundamental. I'm sure all the big operators, I'm sure Mauricio will say the same. Cyber is fundamental to be able to protect the asset as well. And not just our customers' networks. The customers want reliable and secure networks, but also be able to protect the assets. The millions and billions that get spent on these assets need to be protected, and having a very resilient cyber layer has become absolutely fundamental to that.
Yeah, the cyber infrastructure in particular is critical, because what's happening as we advance technology in the space arena and we get to thousands to tens of thousands of satellites in any one constellation, the way that we manage, control those constellations is no longer a human in the loop. It's much more a cyber-based operation. And the other thing that we're seeing is a continuation or an extension of the terrestrial networks from a global perspective up into space. We're going to see that more with 5G implementations in space. And so as basically the threat that we see of cyber in our global terrestrial networks is going to extend into space. And as space continues to implement I'm going to say, networking architectures across spacecraft, then the cyber threat in that infrastructure is going to increase in a similar fashion. So I don't think there's going to be any distinction at all between space operations, space command and control, and network management in space than what we see in the terrestrial network environment. Cyber activity and cyber focus and protection is now becoming an integral part of everything that we're doing.
Maurizio, thoughts on cybersecurity?
Fully agree. Goes back to my point about space assets being part of the national critical infrastructure in a way or other, and think about the level of security and resilience and cybersecurity that the national power grid has, regardless of the country. So our systems, are no second, have no difference in terms of how cybersecurity is treated with the highest level of criticality in our systems compared to those infrastructures.
Thank you. So I just got a ping from the organizers reminding me that while this has been a fascinating conversation, we probably need to wrap things up because we don't want to impede on our either our panelists or our audience's time. But I'd like to thank you all for a fascinating discussion. And if I may, if I could get every panelist to give me just like a 30-second takeaway, what do you think we should be doing and focusing on for promote space sustainability? What do you think is the biggest thing that have the most impact in the long term to ensure the long-term sustainable use of outer space? Really quickly, 30 seconds tops, starting with Mark, go.
Okay, I'd like to see an accurate model of what the impact of launching a space system is, how it impacts the environment and how it impacts the other systems around it, to be able to make informed decisions about what we're putting into space before we do it.
Great, thank you. Frank, sorry, go.
That's all right. From my standpoint, I would say recognizing space as critical infrastructure, like we do the other sectors, like automotive and the airline industry, financial sector. Those are all seen as critical infrastructure. Space today is not officially recognized as critical infrastructure by the United States. And I know the European Union is looking at recognizing it as critical infrastructure. I think we should be making a step as a community in that direction.
Thank you. Last but not least, Maurizio, thoughts, 30 seconds, go.
From my perspective is the recognition of space as natural shared resource, that is a finite resource, and linking access to space to market access and access to finance.
Great, thank you. So with that brings us to the conclusion of this webinar. The questions, we had a lot of great questions in our queue. The ones we did not manage to answer during the live program will be responded in writing and posted next to the video on GVF's website if they're relevant to the topic of our discussion. You will be able to watch the recording of this and previous webinars on the GVF website, which is gvf.org. So with that, join us again for our next event, 5G and Satellites, Hope or Reality, which will be Thursday, December 15th at the same time, 3 p.m. UK time, 10 a.m. Eastern time. So once again, thank you, the audience, for your time. Thank you, panelists, for your questions. Hope everyone has a great day. Thanks a lot. Bye-bye.